Okay, record it. All right, so maybe we can get started. Okay, good morning, good afternoon, and also good night, good evening to everybody, and welcome to our latest seminar on AI agent. So today we're happy to have Sibasis from Walmart Global Tech with us, who is specializing in AI-powered microservices and cloud performance optimization for financial applications. So Sibasis recently promoted to a senior IEEE member, work on bridging the gap between real-time reliability and scalable architecture by embedding resilience and intelligent tuning in cloud-native systems. All right, and the Sibasis is I would say, regular speakers at international conferences and mentors engineers and building secure high-performance systems. So without further ado, we're excited to have Sibasis bringing his new thoughts on building AI agents in financial sectors. Now, let you take the floor, Sibasis.
Yeah, thank you. Thank you so much, Dr. Tao, for introduction. And I would like to thank you for giving me this opportunity to showcase my work and my industry experience to the world. So, hi, everyone. Good morning, good evening. Welcome to the Symposium for Rising Star. And I am Sibasis, and I'm staff engineer in Walmart. And my expertise is on Agentic AI microservices for cloud performance optimization. And mostly I'm dealing with the FinTech area now. And I will start my sharing here. So, and I mostly love to speak in various events. And this year, it has been a fantastic year for me, where people have been accepted me for various speaking opportunities in IEEE SSCT recently, and AITP as as a volunteer organization where I regularly speak. So this is some of my speaking engagement work recently on this year. So in the June, I presented my paper on IEEE poster Agentic AI, and last week, Monday, we had a DMC conference where one of my other paper also got accepted, and I presented that. I went to Louisiana for a speaking event, so I would like to thank IEEE, Dr. Tao, to accept me for this speaking opportunity. So now coming to today's topic, okay, I'll just go 2 slides back. I have my QR code in the first slide. I always start with this saying that in all my speaking engagements, online, offline, I see that people hardly nowadays listen to somebody, mostly 5 minutes, not even 5 minutes or 1 minute. In my 1 minute video, which I post, usually people have a patience of hearing 20 seconds only. So this is the trend going on today. All these analyses are from LinkedIn, my speaking engagements. So I have the QR code. That's why in the beginning. So I love everyone who are present here to scan it, connect with me in the LinkedIn for any further questions in the future. So today's topic, we have a 1 hour time, so I'm not going to take much time. I want to just tell what is the fundamental concept that's going on today in the industry on agentic AI, and how we are building services through agents that help the clients, the customers, ship the product in a very fast manner through security as well. So FinTech is a cyber physical system. So today's topic is a cyber physical system, and that's none other than FinTech area, where we can easily, how it's a mission critical and how we can tag or relate FinTech to CPS. Right, so FinTech platforms now operate on a mission critical application. We can say FinTech are mission critical. Why? Because any failures, right, it can delay billions of transactions and privacy or compliance. So why I'm telling this is, right, so finance applications, wherever your payment system or you are doing some forecasting or planning on your company, right? If there is a small delay in the transaction, or customers are waiting for something to get an output, then it's a very dissatisfaction for them if there is a performance lag. So in my recent research, where I did some analysis, how an AI agent can help us to have this problem. So today we are solving this problem as well, but with the human intervention. For example, if there is a performance issue in production, we still wait for it to get fixed in the next release cycle. That is one, right? Second one, if there is a security issue in your library, then again we wait for your next release to happen to fix. So how can AI agents help this to fix automatically? One more research has come into picture that when there is a performance delay, you are going to get your cyber attack. Your attackers are waiting. If a transaction takes not even few seconds, right? So that network connectivity time is enough for hackers to get into your system and hack your system or the transaction. So financial platforms are very important in two perspectives. One is your performance, and second is your cybersecurity. So what is the challenge we are having in this industry today, right? How we can maintain trust. Now, since AI is coming into picture this year, agents are coming into picture. That's a buzzword in the industry. How customers can trust AI, right? The application, the company, right? And how we can be a zero trust compliance, right? How we can be security with AI go hand in hand along with the performance so that your applications run smooth and you don't have any problem running your application smoothly. Plus the trust. Trust is a very important factor in the customers. If once the trust breaks, then they are not going to use your product and we are in problem. So what are the threats today that can stop us to do that, right? Cascading failures. Application 1 calls application 2 calls application 3. So that's the microservice architecture that runs behind the scenes. And let's say there is a delay between application A to B. That means there is a ripple effect from B to C, C to D. The total number of services, everything goes slowed down in the backend. Then what happens is your application is slow. That gives a chance for attackers to attack and go and do some forgery items, right? So those are the threats: cascading failures, service drifts, fraud injection, and anomaly propagation. So these are some of the problems we are already having in the industry. These are getting today solved through human in the loop. Human sits down, solves the problem. Users wait for that to be getting fixed. So my research initially was on how can we improve the performance through agents, because we know that agents, LLMs are vast, knowledgeable agents. How we can use that and automatically fix these problems while you are in production itself, rather than waiting for human to come and fix. So we'll see that in a while how my paper got published and what are the research I have done that. And from there, in my second talk and the research, how I have related the security in the performance together, where the research is still on, and we'll see that as well. Okay. Coming to what are the principles of CPS in the FinTech? So how we know that your cyber physical systems have three components. One is computation, communication, and control. How that is linked to FinTech microservices. So here I am always saying about FinTech because that is a critical service in the industry, and I am working on FinTech. But these concepts are equally applicable to any application in the industry. Let's say telecom or healthcare. So those are also important domains in today's world, right? So these concepts can be easily applied to other domains as well. But my focus is on FinTech because that's my domain of work, and that's why I talk about it. So there are three components here, the principles like sensors, controllers, and actuators. Sensors is nothing but telemetry and events. So whenever the applications are running, how we can collect the telemetry logs, the events that is happening throughout that application. You will have n number of services, you will have n number of calls, collect all those information. So those are telemetry, those are the logs. Controllers, that's where the important thing comes into picture. There will be a AI orchestrator that will be monitoring all these services, what logs it can capture, what are the metrics, what are the events that are happening throughout. All will be monitored by the AI orchestrator. And that's where the fraud engine comes into picture. AI orchestration will have two things with within it, right? One is how to monitor and see what are happening between the services. And the second one is your fraud detection. Along with the performance, how can I detect fraud? So those can go inside the AI orchestrator, and agents can help us to do that. And finally, the actuator. So that's where your transaction and services and APIs are coming into picture, right? So that's how we can easily relate AI into CPS. It's kind of an infrastructure. In that infrastructure, how can I have an agent sitting down monitoring all the services through services call, their performance, how they are behaving, collect all the logs, and there will be a fraud engine. Fraud engine, nothing but an security fraud. Sorry, I want to say an AI agent who detects the fraud. Coming to, yeah, that's what I talked about. How security is important, and that helps in resilience. So in fintech, we know that milliseconds matter. Transaction A calls transaction B, and let's say there are 5-second delay between them. Now that give a chance for fraud. I mean the attacker to attack in between and see, since the transaction is in state in progress, a network can be hacked and they can go and easily, if it's a financial transaction, then it's a very danger thing, right? So security is very important, and the resiliency as well. So how we can mitigate the downtime risk? So that is one of the another problem. So one is the performance, second is resilience, third is optimization. So all three goes hand in hand for any cloud applications today. So operational downtime causes financial loss. So let's say there is an attack, and due to that attack, there's a ransomware, and the ransomware has killed your application, right? So that means you are in a downtime. Even though you have multiple services, three services, your service one is down, and that means the ripple effect starts. So what happens in that case? So how we can mitigate that downtime risk, right? How we can prioritize the security. So all we will see now. And if there is a complex dependency between the service, let's say in the modern architecture, mainly in the microservices, we know that they are always vulnerable to attacks, right? Why? Because each services will have the dependency. They have their own logic, and each service is the API to API call. So if an attacker they can easily go to service one or service three or service five, they can easily figure out if they are not safeguarded, they are always vulnerable to attacks, because there might be a deprecated library running in your production if you have not fixed. Those are already vulnerable, and they know if they can detect that version is in your application, they can easily go and hack it, right? And what will be our key resilience metrics to decide that? Mean time to detect and mean time to repair. That is MTD and MTR, right? We all know that how those are important to um, for an application to make it resilient, right? And that's the last one, self-healing systems. So we don't want our applications are running in the production system to break. Human comes in, solves the problem, and that's where the time wastes happen. Now AI agents will sit in between to monitor all these things, what is happening, and fix then and there itself, right? So that's where the agentic AI comes into picture. So AI is a buzzword we know from last, 1.5 years with the evolution of Gen AI. And this year, Gen AI was last year, and this year it is completely agentic AI. So I can give a quick definition here. So what are agents and what are agentic AI? So agents is nothing but you can say an automation we are doing to a particular task, and based on the analysis, it takes a particular action, right? Automation plus action is your agent, and it stops there. But agentic AI, you can think of a microservices, service one, two, three, four. What your services, five services were doing, your five agents will do that now, right? So that's where your agentic AI comes into picture. Multiple agents talking to each other, solving a problem automatically. They take a decision. Okay, I get my data from application A, B, C. I do some analysis. We talk to each other, and that's where, and I take a decision. So that is called as an agentic AI, right? So that's what I'm talking about here: autonomous perception and action, and continuous feedback. It's not that they take an action. So we need to monitor somewhere why they took that action, what happened, based on what parameters they have taken that decision, what data they used. So all those has to be captured and kept so that you can do the analysis later, and you can train your models so that they can behave well in your next, right? Context aware. Context aware is very important, right? Without any context, agents cannot perform their task. So for any action, any task, we need to give the context. And on top of this, security comes in handy. Your cyber system or cyber critical system, whatever we do has to be zero trust. Nothing we can trust, right? Because whenever it comes to any enterprise applications. So autonomous perception, continuous feedback, and your context aware. Three things are very important defining your agents, right? How you can do a fintech automation, right? So traditional way, we know that static rules and we can say a rule-based orchestration. So if you go to any finance application today, if a finance manager is analyzing, they will have a set of rules. If this, I have to do this. If this, I have to do that. If this is my parameter, my planning and forecasting will be this. So they have a set of defined rules, right? What if, and those are static rules. Now those rules are, we are going to feed it to the AI, and AI is going to take a decision based on the conditions you are in today. So if you see in finance applications today, right, whatever we are seeing in the industry, every year, based on the conditions, based on the sales, based on your, since I'm in the retail, we are in the sales applications, right? Based on the sales that is happening in the retail, our financial analysis and forecasting, every year it changes. So the static rule changes every year and the rules are defined by the finance managers. How can AI do that, right? That's why we rethink how can finance, fintech can automate all these tasks, right? So we need system that learn from performance degradation. That is the first thing, right? And it adapts to security and it optimizes the resource allocation automatically, right? Latency, security, performance, all goes hand in hand, right? So agentic AI for resilience in cloud native fintech. So once all these three are combined and the actions are taken by the agents, that's where we can say that for cloud native fintech applications, we have achieved or we have created an agentic AI solution, a resilient agentic AI solution. So once this came into picture, how did I use agentic AI in one of my papers to show how we can increase the performance? We can develop applications which can auto scale, it can automatically cache, and it can automatically load balance. Automatically here, what I mean, an agent can sit and do all this by itself. So quickly, I'm going to highlight that paper here. Sorry, here. Oh, zoom in a bit. Yes. So this paper was published. I can share the link. So this was the first paper I did on agentic AI for microservices. How can performance be improved through agents, right? So if you see here, three things that can improve the performance of any applications. One is how we can auto scale. So today we know that there's a Thanksgiving, sales are coming more, people will be now 100 to 1 million people are going to use the application. So what we do before that event, Thanksgiving, we go and set up our environment like that. Now future, we don't need that. Agents know that, okay, Thanksgiving is coming. My previous year's data is this. So what can be my this year's data? Automatically, it can scale to that. We don't need a human to sit down and change those configurations. Similarly, predictive caching, right? If a application is calling a database and for a particular table, so you know our industry, right? Our industry APIs, your service calls to database to a particular table. And if that table data is static, we don't need to call again and again. We can call once and cache it, right? So today, how we are doing? So in our design phase, we go and analyze. We see that, okay, API 1, API 3, API 5, we can cache it because those are static data. Now, what if AI agents decide for that? So we don't need to go sit down and analyze those because we have seen that mistake. Today, we design, sometimes we might miss, okay, table 3 today is not cached, but after few months, we can go, it might need to be cached. Otherwise, it will give a performance degradation. So AI agents can do that. Third one, right? Load balancer. I have two servers running, and on the Thanksgiving day, I need 5 servers. So I don't decide that as a human that I need 5 servers. So based on the load, your agents spin up another 3 servers, right? So these three topics is what my paper presented, and I don't want to go deep into that. So where we saw an improvements, I saw an improvements in all those caching, load balancing, and what was the other one? Caching, load balancing, and scaling. Right? These three, I saw an improvement, and automatically agents can do that based on the data they have from the previous years and data they have in the current year, or predicting the future. So to test that, I use the data from Kaggle. Anyway, it's always whenever we are experimenting, you always know that it's a Kaggle data. So I use the Kaggle data and some normal Python libraries with Gypsum environment, Gymnasium, and that help to showcase that how these are has improved. You see here how the round robin, how the server has improved the time, how it can the cache hits, cache mesh, and it can scale. So this was a very good experiment for performance improvement. Now this did not talk much about the security are part of it. So security and performance, as I already said, always go hand in hand, right? So in the next, when I was invited to talk about, I can, yes, talk about how threat detection can come into this analysis, right? So when I was working with a professor in Arkansas University, so he suggested me, why don't you check how the performance can be integrated with the security? So when I went and analyzed that, yes, so that's a very important factor, right? As I'm continuously saying that if your transaction A calls transaction B and there is a lag of 5 to 10 seconds between them, that's where it gives an attacker to go in and disturb your application. So how we can prevent that? So in my analysis, so here, yes, if you see this diagram, right? This is not in the current PPT. I can add that later. If you see, your agents are sitting here. This is my request CPU. Reinforcement learning is always that's used for the agent. And how a secure action can be done in between so that it always checks what's happening between transaction to transaction. Your application is healthy or not. And if you see here, the secure interface is sitting here, right? My API gateway is here. All the microservices or your services which you call are running. Agents is in the between. Now, agents play a crucial role checking the performance here and also the security, your threat scoring, your rate control, and isolation, right? So these completely form a cloud infrastructure through agents. So this is the future, right? The future is coming, and that's where we are heading towards. How can things can be done through an agent? And of course, for first few years, and not I can say first few years, depending on how your model and your application behaves, human in the loop is very important. If human is doing 100% of the work today, now they have to come and sit down and monitor how are the things happening once these agents are deployed. And that human in loop is very important for first few years because their feedback is very important for models to perform well, right? Now back to my presentation. So what we are talking as of now, since I'm going in a very fast mode, right? How enterprise applications runs today. This is a quick recap. Enterprise applications runs today in industry. Mainly, I'm talking about FinTech. How performance matters in FinTech. Now, when you click your app, you are doing a payment within milliseconds, you are getting a response. This much debited, this much credited. You are doing some analysis of your future planning and forecasting. How can that be done very fast without performance degradation so that you gain your customers are happy and you gain their trust through AI? With this performance, how you can integrate the security? How security is important when agents are doing all this work? How can threat be detected while your agents are monitoring? So your multi-agent system is your agentic AI. How your agent secure agent? and performant agent work together to make your application run smoothly in the industry today. So this is what we have discussed so far. If any questions, you can stop me. So as we move forward, this is what I talked about, my SSEET talk recently in the Louisiana University. How can a secure agent, resilient agent work together to perform a better application and a cloud infrastructure? Coming to zero trust and agentic AI. Yes, so this is what I am experimenting now, and soon I'm going to publish a paper as well. Right? If you see, I'm not going to read out here. I'll just go through the diagram. Right? Our applications, microservices are running in a cloud infrastructure. Right? We are calling microservices because we know that everything is behind is a service. So it can be nowadays there is no monolith. Everything is a microservices. We know how it helps in scaling, how it helps in keeping the system healthy, resilient. So all microservices APIs are running here, and we on top of that we have a service mesh. So that is a microservices to microservices call are handled through Istio and routing. So we can go through that in deep later if we want how this happens. On top of that, we are going to have our agentic AI trust layer. So here I am saying trust evaluator. So this doesn't mean only the security thing, right? Zero security mesh. So if you see a routing mesh, a security mesh. So these are the kind of agents that are going to sit on top of microservices who are going to monitor your security. So this is completely focused on the security part. But if you see, there will be another layer coming here, which will I mean, check your performance, your optimization, your caching, your scaling. Both are going to work parallel hand in hand, right? So quickly going continuous verification, how these are adapting to secure policy, how multi-agents collaborate with each other. That's very important. That's where agentic AI come into picture. And that's where your application will be robust and fail safe, right? If there is any problem, how can we do a quick rollback? And if there is any threat, how can your services behave smoothly without impacting the user? Because user, as of now, until today, we were taking care of users' application. If application breaking, user is not happy. But now we are going to inform users, clients that, okay, our applications has agents on top of that. And once agentic AI or the AI word comes in industry, now users are very much, you can say what we are seeing in industry is they are very scared because AI, they think that the data is going to get leaked. They don't trust the AI. And if system doesn't behave through agents, then they will not trust the company as well. So we need to be very careful. We need to work with users. We need to work with clients and tell them, okay, this is my agentic layer, how we can trust it, how human in the loop helps to build a secure system. This is where we are now, learning and safety. So whenever we are introducing a model, right, we are having, let's say, chat GPT is the one which is very famous now. I mean, most of the industry are going towards that. But there are various agents as well for coding, for searching and all. Different agents behave different. But for application specific needs, 90% are using GPT-5. How your AI agents can build on top of GPT-5 LLM to do your autonomous tasks, right? And that agents need training time and then. So while we are in the application, we need to fit the context is very matters, right? And here the memory also matters. How much context you want to give to your model so that it learns, it plans, and predict. And everything needs to be in a guardrail. So you cannot leave your agent as it is. Now, for example, if you are giving an access to LLM to your database, you just cannot give a complete access, read-write access, right? A simple basic thing. So recently you might heard a news that a model was given a complete access to a database. So even though the instruction was to add and view, it went and deleted some records based on the prompt. So we need to be very specific for safety and what guardrails we are giving to the database, right? For example, human override. If something wrong happens, Human in the loop, as I said, needs to come and correct it. How we can roll back? Some problem happens. How we can easily roll back without impacting the customer, right? What are my bounds? I should not go whatever my boundary is given. Your AI should not go beyond that. For example, I give a read access only to the database so that it cannot go and write anything until I give access. So what are my safeguards to that? So all these things we need to consider, and your agents learn by itself because your LLM models are already trained with vast data, right? Whatever the new things that comes up, we need to give it as a context, and whatever the memory it has, both it can combine and it can act. It can plan and it can predict, and once it predicts, it can take an action, right? So collaborative fault mitigation. So there are not going to be single agent today in future, right? For a particular application, multiple agents are going to work together automatically to take your performance and security into picture, right? Multi-agent systems support each other to efficiently handle faults. Definitely, that's going to be the future. Now, balanced reward function, reinforcement learning. You might be heard about that, or if you're a college student, definitely reinforcement learning is the one. That concept is used everywhere. You reward to success and don't reward to failures. That's where your model learns, and your LLM and your agents are built on that. Fail-safe mechanism. So safety and learning, these two are going to be very important when you are building agents and in your cyber platform system, how you can integrate that for a very good application which you are going to build. One more advice or industry advice I want to give it here is the future is going towards a solution where you can bring agents. So whatever solution you are going to or a particular problem customer brings in, you need to get AI into picture. How can AI solve that? No doubt humans are going to be in the loop, but the first thing is how that problem can be solved through AI. Always you have to keep in that mind. So evolving CPS perspective, right? How it can be evolved. So our classical models were like sensors, controllers, actuators, and system. This is where we were previously. Those are static, right? Those are classical models, deterministic. So we know it's rule based, right? If A, B, C, D is my path, output should be E. Those are static paths. Those were defined by users. Right now, it will be agentic control. Your applications are running, your services are running. You get your telemetry logs, you get your telemetry events, put it into your agents, right? Agents observe that, learn from itself. How it learns, we give a prompt. So you are a ABC agent. This is your context. This is your data, and don't forget about the policy, right? That's very important, right? And based on this, I have to take a action. What kind of action? As I said, an example for performance, caching, right? I am hitting 10 APIs, keep monitoring which API is hitting database and check the table. If it is a static data, automatically cache it. If you see that there is a change in the table for that, change in the data for that table, then you uncache it, right? A simple example. Agent does that for us. So those are the requirement we need to fit, right? So telemetry, agent observes, checks the policy, and take an action. This is what the future is going towards. Deterministic control. So traditional has deterministic. Now it is probabilistic, right? So our thinking should be towards that. What context I can fit to my model so that it can take an action. Whatever problem we are solving for a user, how can AI come into picture, right? Recent conference, I was in a power electronics conference, and my paper got selected there as well. And I tried to use this agentic AI microservices concept in the EV charging station. So those are all softwares. So I could easily relate to power electronics as well. So, and that paper got selected. I was also surprised. Why? Because whatever we think today, right, all those needs to be through AI. How can AI solve a problem? No doubt human needs to be in the loop. And we are not replacing 100% human here, right? So those users also needs to be learning AI, and they can be in the loop to solve the problem as well, right? So probabilistic, previously deterministic, now it is probabilistic, right? And how we can handle the security. Similar case in security as well. Sensors, controllers, actuator system. Agent monitors you're secure. What secure is the transaction is secure or not? Somebody is calling an API through a what we call as if you know they can have a JavaScript in the URL, pass it and they can directly go into the database and read the data. Is the transaction secure? Can the agent monitor that? Yes, agents can monitor that as well. They can take an action, they can reject it, even though your microservices has a check layer. On top of that, agents can sit and before only they can reject those transactions. So we need to think towards that and how we can make a safe agents in this AI world, right? So this picture is from my recent experiment, which I have been using static orchestration, how it was behaving and how adaptive, or you can say deterministic orchestration helps in the graph, right? So what are the metrics we need to measure when we are developing these applications? One is, as I said, MTTD and MTTR. How can agents help us to bring up keep the application resilient, right? Secure, and how they can learn. So these three are very important features. So in a recent industry example, I can give, right? One is we are using coding agents to build applications fast. That is fine. But once the application goes and deploys in production, who monitors that? We have production system engineers sitting down and monitoring all the applications. We have alerts. All the setups, all those configurations are done by human today, right? Now agents are going to take care of that. I am going to collect all these. So in the recent my applications, we are doing that. We are building agents that are going to capture all these logs, spit out a dashboard. In that dashboard, where you can go and check how my applications is behaving, how many APIs I have cached, what are my APIs timing out, I mean timings, all those things we can do live instead of somebody going and configuring the dashboard for us. So the industry is going towards that, whether it is Google or Amazon or Microsoft, right? All are building agents that can help with this, right? And always when we are building these applications, we need to consider the privacy compliance. This is very important. Your GDPR or your personal data, right? On the standards. So those are industry defined standards and they are not going anywhere. So today, when we are deploying an application in the industry, before going to productions, we have to do all these steps, right? One is review with a legal team. There will be a AI governance team. They are also going to review your solutions, right? It's not that I prepare applications, go and deploy in the productions, right? So in the industry, teams are getting set up. Legal team, your AI governance team, your security team. So all these teams are going to validate your solutions, what information you are giving to your agents or your LLM, right? It cannot be that you are giving your personal information. So they are going through your prompts. So prompt engineering is very important. What prompts you are giving to your LLM agents, how they are behaving, what are the security features in there, right? So we have you can see that we have pen testing in the industry today, right? So your solution is built. Let's say your compliance team has approved it. Next, you go to your security team. Your security team checks. They do a pen testing on all your applications. That's where they come to know how your applications are safeguarded through sensitive informations, right? How your data is monitored, how your reportings are done. So pen testing is done next, right? And whether your GDPR and your AI compliance is present or not. So all these checks are done once your applications are built. So that we call it as a privacy compliance. So what we have done so far, we have built applications, we have used AI, we have solved some problem. Then next we are going through all the compliance checks. Teams are there, they are going to analyze your solutions, regulatory compliance, policy inheritance, how secure it is, pen testing. Pen testing, that's never going to stop. Now it is more robust, right? I mean, it has become more important plus robust because AI come into picture, and we know that we till now in the industry people are not trusting AI. So pen testing is very important. And finally, your privacy reserving control. Research drives privacy-focused AI controls in cyber physical system. Now, trust is very important. So your privacy compliance team, security team does that for us. And in future, right? I talked about fintech. So since starting, I told a word that these solutions are not only for fintech. It can easily be adapted to IoT, right? Or any other applications. Let's say a telecom. Whenever you are building applications for telecom, or whenever you are building applications for healthcare, these are very important. IoT, right? Every minute, seconds, there are IoT sensors where we are sending the data. So now somebody is reading that data and taking an actions. Agents are going to do for that. Not your static rules or your you can say deterministic. All are going to be deterministic now in the future, right? So this is the cross-domain impact that's going to happen in future. So I have a fintech automation agent. I am taking my agent taking the automation decisions. It can send the data to an IoT device, and your IoT device sends the data to future agents where they are taking the actions, right? So in this case, so once let's say today we have I mean less agents. From this year and starting next 2 to 3 years, there is a prediction that everywhere there are going to be automation and agents, right? So how we can mitigate that challenge? How all these agents can be secure, right? First thing is explainability. So whatever applications or agents we are going to build, right? There needs to be a clear explanation of automation decisions. Why we have taken that decision. That is very important. Even though the paper I have done and the experiments I have done, I am capturing that information. Let's say I cached an API. Why I cached? Because I saw from last 2 days, 3 days, the data is not changing. That's why I cached. After 5 days, the data changed. I uncached. So that why has to be captured and kept somewhere so that in future I know that LLM agent has taken this action because of this. So that's explainability is very important. Otherwise, we don't know why that has happened because agents are doing for us and we never know why that is done. So that has to be captured somewhere, and human in the loop who does that can sit down and verify that, okay, things are going as per plan. If not, you have to tune your AI, right? And managing trust, agent trust, right? Establishing and maintaining a trust among autonomous agents is a very challenging today. So we need to manage the trust. How we can manage the trust, right? If your application, whenever you are presenting a solution to your users, you need to tell them how we are securing their application. That's where the trust comes in. We are not leaking their data. We are doing pen testing. We have AI governance team. We have a legal team that checks all our things, right? So all those are very important to manage trust in agents, right? Interoperability barriers, right? Limited compatibility of control policies across the framework, right? How one agent seamlessly integrate with other agent. These are very important thing, right? And certified AI governance, very, very important in an industry today. We need to have a AI governance team that monitors and approves our solution, and then only we proceed to production deployment, right? So cross-domain impact definitely going to come. Already people have started that, right? So what are the lessons learned so far in this talk, right? One is reliability. Whatever the cyber physical system we are going to build, how reliable it is, how resilient it is, right? Agentic AI systems always adapt to dynamic conditions because LLMs are trained in that way, right? They support sustained operations and they try to be continuously resilient. Even though my prompt doesn't say if something happens, we automatically bring up another server, they do that because they understand the context. This application is built for this context. So they understand it, and that's where they perform it. So resilience with agentic AI, very important. Data trust. We know that how trustworthy it is, right? Ensuring the data trust. How secure is our applications? How the agents rejects the transactions with bad calls? How vulnerabilities are fixed automatically. All those are taken care through agent. How we can ensure that trust with the users, right? And collaboration. So these are the lessons learned so far in the paper I have written, and I'm going to write. I'm still in progress. How your cyber security are going to integrate it with the performance and the governance, right? Governance is very important. Human in the loop validation. Every solution what we build needs to have a human in the loop verifying that things are going smooth in the industry, mainly in the finance system, because finance managers are doing that today. Your Wall Street finance predictions, your all, I mean, finance is very important application where we are dealing with. But the same is with telecom or healthcare. Healthcare is very important as well, right? Your personal data, if it is getting to be exposed, GDPR, right, or PCI, then that's going to hamper the company's reputation, and your clients are not going to believe in you, and you're not going to get your projects to work on, right? So AI governance, human in the loop, multi-agents governance is very important for our future CPS infrastructure. So this is more towards again the same thing, right? There is no other way to talk about it. Security, resilience, and operation. These three are very important. I'm not going to go through again that. And the conclusion. With this, I want to conclude that cyber physical systems are no longer the end in the factories, right? They now run the financial world. Now, what this mean? Agents sitting in your systems. You have your agents monitoring your performance, take action, make your system healthy and faster, right? You have your security agents. Those are sitting in your applications. They are monitoring all these transactions, flagging, right? Unsecured systems or transactions. If any you have vulnerability libraries, flagging that, see what are the fixes so that you can fix them easily, right? So agentic AI ensures security, resilience, and continuity. Continuity is the main thing, right? And industry and academic partnership. So this is what I was talking with Dr. Tao before we start this conversation, right? How academic and industry can partner and help this finish the bridge. Now, why are you talking about academic? Because academic is the one where the new things grow and invents, right? And industry are the one where they are using those and implementing it. For example, LLM. So LLM was grown to academic professors or distinguished professors, right? Those were fed to the industry. Now in the industry, we are using those LLM and we are getting the problems what users are facing and trying to solve that. So industry and academic partnership is very important to bridge this gap. Let's say I have a new security problem in future, how I can partner with industry and solve that problem. Or I can say another example, right? In my recent paper on the EV charging stations, where microservices, my paper, microservices can help EV charging stations to be resilient. How I can do that and show the students and industry, partner with industry. Because whatever I done experiment is through MATLABs and it's remain in my system, right? How real world people can use that, how I can verify that solution with industry, right? So industry partnership with academic is very important. Academic is the one where students and PhD researchers can vet my solutions, they can use it and they can sign off, okay, this is how it works, or you can face this problem in the future, right? So CPS research is entering the fintech frontier. Yes, that's a very important thing. How our cyber physical systems are entering in the fintech industry, and we can keep it very resilient, secure, and performant, right? Optimization. So with this, I would like to thank everyone who has participated here and listening to this talk. And I hope it has definitely made some impact on how agents are going to take over the industry in the future, and how from now on this year, we have moved towards building agents, agentic AI solutions to work along with the microservices and services we have today in the industry. So if you have any questions or if you want to connect with me in the future, you can go to my website or connect with me in the LinkedIn as well. And with that, I want to end my talk here. Any questions I can answer now.
Thank you very much.